Hi everyone, I'm sorry I couldn't be there today, but I hope your homework review and your mini quiz on dilations went well. What I'm going to do for you today is show you the first three examples on the worksheet you were given, and then I'm going to ask you to try the fourth on your own and go ahead and check the answer with the key that I will be posting on Google Classroom. We're going to be doing compound transformations. Now, something just at the start that I'd like to point out is that you're going to be seeing me use an open circle symbol. Now, that open circle symbol will be familiar to those of you that have done composite or compound functions. Some of you may remember that if you were in algebra theory last year especially, but you might have this symbol from functions when you had a function named f and g, and it actually told you that you did them in order from right to left. So what you essentially would be doing is going backwards, because that open symbol means the word following. So last year, if you did that concept, you would pronounce what I have written on the side of this line as F following G. And since F follows G, G comes first, F follows it later. So you're going to see that in just a second when I talk about this first compound or multiple transformation that we're going to do with point F. So I'm going to go ahead and plot point F on the coordinate plane here. It is -4, -6. So I'm going to go ahead and put that there. And so what we're going to be doing with point F is a dilation of 1/2 about the point -2, 2, which means it is no longer a dilation centered at the origin. Instead, it is a dilation centered at -2, 2. Now, because the only thing that we have done dilations with so far is when we go ahead and dilate from the origin, we will have to move this transformation to the origin in order to complete it. So what we're going to do is we are going to take the point -2, 2 and turn that into the origin of 0, 0. And that is going to be done by translating that point. So essentially what we do in order to move point F via a dilation centered at a different point is we translate first 2, -2. Because what you will notice is translating to -2 will turn this point into 0, 0. Then what we're going to do after that is actually complete our dilation of 1/2. And then, because of the movement we did at the beginning, we will have to shift everything back to the point -2, 2. So essentially, we undo the translation we did at the start. So we are going to go ahead and take point F, which was -4, -6, and we are first going to complete that translation of 2, -2. Because that point will also shift along with the center of dilation. And that is going to temporarily become -2, -8. Because according to our translations, what we do is we add the values to the x and y respectively. What we will then do after that is complete the dilation of 1/2. I'll be moving to the next line because I'm running out of room. And if we cut those values in half according to our dilation rules, it will turn into -1, -4. And lastly, I will have to move the translation back, and I will do -2, 2. And so if I go ahead and make those motions, I now will have f prime, and f prime will be -1 -2, or -3. And 2 -4, or 2 plus -4, if you will, and that will end up being -2. And so now I know -3, -2 is the location of f prime. And that would be typically the work that you would show on the coordinate plane for this transformation. But just to show you what actually is going on here, if I plot the point -2, 2, which was the center of the dilation we just completed, you might be able to see visually that the distance from that point to point F is now half as much as it once was. So we essentially did dilate by 1/2 with that as the center instead of 0, 0. So that is one type of compound transformation. When things aren't centered where they're supposed to be, you have to move the new center value to 0, 0. After you move that center value to 0, 0, what you will end up doing is then complete the actual transformation mentioned, such as dilating by 1/2, and then you will move it back. The example 1 down below this is the other type of compound transformation, which is spelt out a little bit more for you. We are going to be plotting triangle DOG. Then we will be plotting DOG prime, which is something after a translation has occurred. And then we'll be plotting a double prime figure, which is the image of the one we had just left off on after a reflection in the x-axis. So we have a couple of things going on here. If I wanted to write that symbolically, I would write that as a reflection in the x-axis following a translation of -3, 3. And that's because, remember, that open circle, meaning following, actually has us do the information from right to left. I'm actually going to go ahead and take that and move that over to the side. Maybe I'll move it down here so it's still visible, just so I have enough room to actually go through with all of the motions for the transformation that we have to complete. So eventually I'll plot DOG, but let's actually get the coordinates for everything first. So I'm going to first perform a translation of 3, 3, which is going to get me DOG prime. So I'm going to subtract 3 from all of the x values, giving me -2, 1, and 3. And then I'm going to add 3 to all the y values, giving me 3, 10, and 2. And so that is going to be DOG prime. What I'll be able to do after that is I'll take DOG prime and I will turn that into DOG double prime by doing the reflection in the x-axis. And you might remember, reflecting in the x-axis, you keep the x and you change the sign of the y. So where we had left off in my green writing up top is x's of -2, 1, and 3. And I'm going to change all the y's to be -3, -10, and -2. And so as we plot these, we're going to see DOG, then DOG prime, then DOG double prime, the original sliding over via a translation, and then flipping over via reflection. So I'm just going to make this a little bit larger so that we can see the points with more ease. So we're going to plot 1, 0 for D. Then we are going to plot, let me make this a little bit thicker. We're going to plot 4, 7 for O, and 6, -1 for G. And I'm actually going to save the labeling for a little bit from now because I don't want the letters to actually blend in with the dots or the lines of the triangle. So I will label those after the fact for you. DOG prime is -2, 3, 1, 10, and 3, 2. And what you should notice as you draw these lines in is you can see the original triangle. Oops, I think I did something wrong there. Let me correct that point because it is 110, not -110. And we will connect it, and you should see that it looks like it is the same triangle, okay, even facing the same direction, but just slid over or translated. And then we will go ahead and we will plot GOG double prime, which is -2, -3, 1, -10, and 3, -2. And you should be able to tell that that is the picture we just left off on, but flipped over the x-axis. And so I'm going to go ahead, now that I won't interrupt these labelings with any other points. That is DOG. Then I will do D prime, O prime, and G prime. And then I will do D double prime, O double prime, and G double prime. And so from the black picture to the blue picture, that is the compound transformation. However, this one asked us to show that middle step of work. So I also have DOG prime. Right, we are going to look at the last example. If you feel like you need to look at this one again, though, go ahead, rewind, and then take a look at this one afterwards. But we'll continue on. If you just wanted to keep watching, maybe you can, rewatch the entire thing at the end if you want. So you're going to notice that I do call this one double prime, but I actually don't ask for us to plot the ELK prime in this case. I only ask for the very start and the very end of this compound transformation. So I am only going to plot two pictures, although I will go ahead and show a middle step of work for ELK prime once I go ahead and figure out the first thing I have to do. So we use the following symbol there. It is that open circle. And what we are going to do is a dilation first, and then the rotation of 180 degrees. So I will be plotting this so we can see it in motion. Let's look at -1, -1, 2, 2, and 3, -2. And this is going to be ELK. I'm not going to label it yet for the same reason I said before. I don't want the letters to get muddled or in the way of the lines. And what we're going to turn that into is -2, -2, 4, 4, and 6, -4, because we are basically doing a dilation of 2 or just doubling everything. But I don't have to plot that because it didn't ask me to. So I'm going to pick up where I left off with EL and K prime, and now complete the rotation of 180 degrees, which will give me E double prime, L double prime, and K double prime. And if you remember, the rotation of 180 degree rule is to just switch the signs of both items. So -2, -2 becomes 2, 2. 4, 4 becomes -4, -4. And 6, -4 becomes -6, +4. And there is going to be a little bit of overlap because what you might notice, and I'm going to erase this highlight in a moment, but we have one of the lines of triangle ELK going through the origin. And so since this is centered at the origin, because I didn't say otherwise, it is going to be flipping around, and that line will still be passing through the middle since the original one did. So what we're going to have to do with that is just be a little bit careful with our labeling. So I'm going to put 2, 2 on there, which happened to also be one of the original points. So we're going to have to double label that later. I'm going to go to -4, -4. And I'm going to go to -6, +4. And now let's label everything once I get these lines in. So you can see I have a little bit of overlap between my triangles, which is okay. Just carefully labeling it. We had E here, we had L here, and K. But then that L was also the location of our new E. So this is E double prime. Then I have L double prime towards the bottom left and K double prime to the upper left. And you can see that both things described do happen. It grew, okay, the line segment lengths did double in length, but it also turned around 180 degrees. So it grew and rotated to go from start to end. My suggestion at this point is go ahead and take a look at these 3 questions that we looked at. If you have to, go rewatch some parts. But when you feel okay to try this next question, go ahead and try example 3, which is just spelt out for you. I am asking you to plot all 3 stages of this question. And you can see the single prime is a rotation of 270. The double prime is a rotation of 270, which was already completed when we did this one, but then you're adding in the reflection in the x-axis.